All right. So let's take a look at this document that I sent to you. And you should be on the page that says 1.3. Okay, yeah, it's estimating slope of the tangent line, I think is the name of it. Estimating slope of the tangent line. All right, and there's not a lot. I mean, we're going to go through this, and if you get behind or you get kind of lost in a little of this, it's okay. I mean, the reason I sent this to you, and what I hope sometimes the calculator allows you to do, is if you want to take advantage of it, you can. It gives you a chance to manipulate and physically move some things on the screen to maybe help a few more neurons fire or whatever the heck they do in the brain that might make some sense to you. Maybe it doesn't. Whatever, you may not need it. I don't know. But what we're trying to do here in chapter 2 is we're going to take all this chart stuff that we did in chapter 1 and all this stuff about slope and derivative and rate of change, and we're going to try to get more specific with it now. We're going to, instead of just doing it with graphs, we want to, and estimating, sketching tangent lines and estimating, we want to actually come up with some actual equations for slope. We want to come up with some actual better answers than what we were doing. And for that, we're going to need some equations. Now, we're going to do it with tables of data too, and on tables, about all you can do is estimate. But we want to work some more with equations, all right? So we're going to have to get a little more specific with what we're doing and get some notation involved here, all right? So what I want you to do, this first part, this should be nothing new. I mean, what we have here is 2 lines, or excuse me, 2 points, and we got the line between. And so we can do that slope. All right, slope between 2 points. Matter of fact, if we're going to maybe get your notes out here, and we'll, as we go along, maybe some things we could start to write down here. Kind of our emphasis for today. You know, I've talked about this before, where, you know, matter of fact, the very first day we did this, we were talking about the door opening, and we want to know how fast is the door opening at 1 second, right? And so, you know, there's not going to be a lot new here as far as the whole concept, but the notation will be the key. So let's review some of this. So in algebra, we did slope between 2 points. Right? I mean, we just did slope between 2 points. Another way of saying that is, if we look at that graph on our calculators, it's slope of a secant line, you might say, for us in this, because that's what you call that, a line, this line here, that touches the curve in 2 places. You probably remember that from geometry. That's called a secant line. Okay? So when we talk about slope between 2 points, of course, in algebra, you were just doing slopes of lines. So you're doing just lines. But another way of thinking of that is a slope of a secant line. Another term we've been throwing around here is rate of change. Well, this would be average rate of change, is what you did in algebra class. And we were talking about average speed, like what's my average speed from here to Grand Island? Well, I need to know how far I traveled divided by what time it took me. Right? Distance divided by time would be my rate. And so the formula for that was simply this: f of b minus f of a all over b minus a. I mean, that was my formula. Right? So this is all kind of terminology for doing the slope between 2 points. All right. So what have we talked about so far this year that's different from a calculus perspective? Instead of slope between 2 points, what do we want? Slope at 1 point. We want the slope of a curve at 1 point. Instead of slope of the secant line, it's a slope of the tangent line. Right? We want to be where we want the line that's touching that curve at 1 point. Now, if I go back to my calculator thing, that'd be kind of, and this is where you can kind of do this. You can kind of grab that point, so you can click and hold, and it'll turn to a closed fist, or you can hit Control and then click the middle of your touchpad. And then you can just move your finger on your trackpad, and you can just move this point down. Now, you got to be careful. If you move it too close to that dot, then you lose it, and you can't grab it again without grabbing the other dot. So you don't move it too close. But basically, what we've said is we let these points get really close together, right? We did some of that on the last quiz. And basically, that line starts to become the tangent line. Okay, so here we got a secant line, and we move it and get it really close to that other point, and basically it's getting closer and closer to being the tangent line. Okay? But we can't move that point right on top of that other point. Why? They say, then what happens to the slope formula? It disappears. Yeah, I like it. It's gone. 0 divided by 0, right? There's no rise, there's no run. It's 0 divided by 0. So you can't calculate anything if the 2 points become 1 point. So we've got, but we want it to get really close to that happening, right? We want really close to the 2 points become 1 point. Okay, let's go to the next page of the document. And it looks very much like the same thing. The only difference is this second point now, we've actually got the slope has been calculated for us here. Okay, and so we can kind of watch it happen. So as we move this point, we can see that slope's getting less and less and less. And again, don't let go of it, because if you get too close, you might not see it. But as we get closer and closer, we can tell the slope is getting close to what? What's the slope getting close to? It's kind of getting close to 2. Matter of fact, if you go past that point, it's less than 2, and right at that point it seems to be right around 2. Now, I don't know if it's 2.05 or 2. I mean, it might not always come out exactly a number, right? It might be 1.997. I mean, I don't know what it is for sure, but it seems to be it's right around 2. So our job today is let's figure out a way to find what it is exactly. Right? I mean, let's see what it is. And so what we're going to do is, the first part of this is we're going to let the calculator do some calculating for us. On the next page, if you look, we have a little spreadsheet set up here. Okay? And so on this spreadsheet, we've got a couple of formulas already filled in using the capture command. And the capture command will allow us to grab the coordinates of that second point. So then we can do a slope calculation between the second point and then the first point, the 1, 1 point. And we can just set up our spreadsheet to do that slope. So if we go back, let's go back a page to 1.4, and let's just move our Q point out here somewhere around 2, 2 1/4, whatever. Just move it up there somewhere. Okay? Now what we're going to do is we're going to hit Control period, or decimal point. And what that did, we'll just arrow, let's go to the next document, or the next page real quick. What happened is it grabbed the coordinates of that Q point and put them there. Okay? All right. Now let's arrow back to the previous page, the graph again. And now we're going to grab that point, and we're going to move it a little bit closer, and we're going to hit Control period. And then we're going to move it a little closer and hit Control period. We're just going to keep doing that until we get closer and closer. Now, at some point when you get close and then you let go to hit Control period, you may be too close that you can't find that point anymore. And that's actually okay. If that happens to you, that you're kind of done with this page of it anyway. You notice where above the period it says capture. And that's what we're doing. Okay, so anyway, so I'm going to go back to this page, and you notice that your spreadsheet's been filled out a little bit. I've got 7 points, looks like. Okay? All right. Now, what do we want to do in this third column? So let's put our cursor over here in C1. What do we want to put in there? We want to calculate the slope between that point and the point 1, 1. So just subtract the y's. Now I have to put an equal sign first. I'm going to hit an equal sign. And I'm going to put a left parenthesis. And my y value is right here in B1, so I'm going to type B1. Oops, not BB1. B1 minus what? No. Minus what? Just 1. Remember, because my 2 points are this point that's in the spreadsheet, and then the point 1, 1 was the other point. So I'm subtracting y. So B1 minus 1, then I'm going to go outside the parentheses, hit divide, and now I got it left parenthesis, and now I got to divide my x's. Well, this x is in A1. What was the other x? Also 1. And hit enter. Okay, so there's the slope of that first of the secant line when I use that point. Now we can let's arrow back up here. Let's arrow back up and have this highlight. Now we can fill that formula down. Okay, so what will happen when I fill down? Then it'll change the B1 to A1 to B2 and A2 and B3 and A3, and it'll do it so I don't have to type them all in. So we go to menu. So highlight, make sure you're highlighting C1. Okay, go to menu, data, fill, and then when we move our cursor over here, over the C1, we can start moving down. And we're gonna tell it which columns we want to fill. Now mine only goes to 7. You gotta be careful because it's gonna go a little fast. Oh geez. Okay, oh gosh. Okay, okay, stop. Okay. So, oh gosh.
Oh my gosh.
Oh gosh.
Are you recording fast?
I am.
Awesome.
Oh gee willikers. All right, so we got all the way down to 7. Okay, so which I wanted, and it filled in my formula. So if I just look on here at 7, sure enough, I got B7 minus 1, A7 minus 1. Okay, so I got that slope, and it looks like again it's getting closer to 2, but we really can't tell if it's getting closer to 2 exactly, or is it getting closer to 2.05 or 1.997? I mean, how can I tell? I mean, what can I do? Well, I mean, I could do some of that, but I guess what I was getting at is, if I could have gotten that point a little closer, right? If I could have drug that point a little closer and a little closer and a little closer, I didn't get it real close. I mean, I got it to 1.02 and 1.04, right? I didn't get it really close, so I need to get closer to really tell what's going on. So this gives us, again, the idea. It's just, again, it seemed like I'm beating a dead horse here. Over and over, we keep talking about get the 2 points closer and closer and closer, okay, to becoming 1 point. All right, but again, it's just another way for you to see it and see what's kind of happening. If I can grab that point, I don't think I can. Okay, well, that's fine. I got another thing to show you here that kind of gets the same thing across. All right, so hopefully that gave you a chance to kind of see that. We actually did some slope calculating, which you're going to do some kind of by hand. You get to use your calculator to do the subtracting and dividing and everything. But let's go ahead and look at this function. So you might want to draw this picture in your notes here. I've just got a cubic function, just some generic kind of cubic function. We're going to call that f. Okay, I've got the slope of the tangent line, so I'm really interested in this black tangent line here, what the slope of that is. They've told me that is what it is, but I'll believe them. Sounds good. But I want to actually be able to calculate. What would the notation look like so I can calculate this stuff? Well, if we go back to our secant line, let me go back to our notes here a minute ago. All right, so we had slope at one point. We had slope of the tangent line. I know I'm jumping you all over the place here in your notes. Let's finish this real quick. Instead of average rate of change, we're talking about what? Instantaneous rate of change. Okay, and now we're at the point where we would like a formula. But unfortunately, you know, what in the world is that? Because at one point we can't use that formula. That doesn't work. Okay, so how in the world do we get a formula? So we're going to do this. So here's the point A where I want to do my slope. Of course, its y value is f of a. Now I could make a second point B, right? But we're going to label the second point differently. And there's a reason, there's a method to our madness here. We're going to label the second point A plus H. So all that means is it's still different. It's different than A, just like B would be different than A. But it allows us one other thing. It brings in this h. What is h here? What's h? The distance between a and a plus h, right? It's that x distance. Now, when you're doing slope, rise over run, let me ask you again, what is h? The run, right? H is the run, all right? And so let's get the y value of that. What would be the y value at a plus h? Hint. Brenda, say it loud. If the y value at a is f of a, wouldn't the y value at a plus h be f of a plus h? Sure. Okay? So the y value there is f of a plus h instead of f of b, right? So in our notes we had a and f of a, and we had b and f of b, and we do the slope between them. But another way to write it would be this. Okay, so let me come back to our notes over here. So an alternate version of this could have been this. I could have written this as f of a plus h minus f of a all over what? A plus h minus a, that's just h. So it's a little simpler. You might say the top's a little more complicated, the bottom's simpler though. H is the run, we said, and the rise is you subtract the y's, that's the rise, and the bottom is the run. So those two formulas there on the left are exactly the same thing. Just, I called that second point something different, okay? But it allowed me to have the bottom be a little simpler, which I think we're going to find is nice. All right, so if we think back to this document a minute ago, we let me draw in my line now. Okay, so there's my secant line, like we were just doing on the calculator. Now I want those 2 points to get closer together. Well, on my document, I have to do it right down here. So to get those 2 points closer together, what am I doing? I'm letting h go to, no, 0. Yeah, I'm letting a plus h go to a, but I'm letting h go to 0 is what I'm doing. Remember, h is the run, and that makes sense. I'm letting the run go to 0. Now, I can't let it go all the way to 0, right? Poof, right? The formula's gone. I can't let h go all the way to 0, but I can let h get close to 0. Okay? Well, that is exactly what we want to write as our formula. And here's how we're going to do this. We're going to say that it's this same formula. The slope of the tangent line is what this slope is approaching, getting close to, as h goes to 0. And here's how we write it. We write L-I-M, stands for limit, and underneath that we write h arrow 0. That means the limit as h approaches 0. And Mrs. Payne used to talk about limits a little bit, but I'm not sure she gets to that anymore. Does that sound familiar at all? Okay. All right. So we're going to do some work here in Chapter 2 on this idea of limits, what this means. But this is the limit as h approaches 0. All right? And then it's a limit of what? Well, it's a limit of this slope calculation. So f of a plus h minus f of a all over h. Now let's break this apart into its two pieces. This piece right here is simply slope between 2 points. Right? All that is, when you see that part of it, it's called the difference quotient. The difference quotient, because we subtract the y's, subtract the x's, and then we divide them. So it's called the difference quotient. That's just plain old average rate of change. But then this part right here, what does that do to the 2 points? As h gets closer to 0. As h gets closer to 0, the 2 points basically become 1, or get close to becoming 1. And the green line, the secant line, becomes essentially the tangent line. Okay? So everything in our notation is now matching up with what we've been talking about we want to happen, is we want the 2 points to get closer and closer together. All right, so what this part does here is, let's just say makes the 2 points become 1. Now, technically, they don't become one. They just get really, really, really close to becoming 1 point. Infinitely close. Okay? So close that we can tell what the slope is becoming. All right, so it's very important that you understand the two parts to that. Now, this is essentially the most important formula we'll deal with all year long. Most important from a conceptual standpoint, not necessarily from a useful standpoint that we'll plug into, but we will do some of that today. All right, so let's do an example problem. All right, so up here in the corner, let me write down what we've just discovered. What we have just discovered, that little formula we just did, as we let h go to 0, and we let these two become 1, we're essentially finding what? The slope at A. We're finding the slope at A, which we would call f prime of A, right? So that little formula we just got done writing right here is f prime of A. That's what that is. Right? That's what that formula right there is. That is the slope at A. So I'm going to write that kind of up in the corner here. So this is f prime of A. What we've just discovered is that f prime of A is the limit as h goes to 0 of f of A plus h minus f of A. Now remember what h is. H is just the distance between the x values. So that's the run. We want the run to get smaller and smaller and smaller. So we want the h to go to 0. We'll let the 2 points become 1. And then that slope is the slope of the tangent line. That's what we're saying. This is called the definition of the derivative. This is the formal definition, or sometimes it's called the limit definition of the derivative. So in your homework problems, when they say use the definition of the derivative, this is what they're talking about. Use the limit definition. Most students call it the long way. Okay? So we will find some shorter ones, but we got to go through this first. It's important. So the definition of the derivative, this is what this says. All right, so let's do a problem that would do it the long way. Well, I'll tell you what. Let's do but before we do this, off to the side somewhere. Okay. Leave yourself a big gap of room maybe and put this. The algebra way, the slope between 2 points way, would be if I give you a function like this, or maybe you don't write anything down and we'll come back and visit this in a minute. If I said to estimate, okay, this would be more of a chapter 1 kind of idea, estimate f prime of 2 with h equals 0.001. Okay, so what am I just saying right there? With our new terminology with what h is. So I'm asking you to do the slope between which 2 points? 2 and 2.001, right? So you would do nothing more. You would do nothing more in a problem like this, because there's going to be some of this on your homework. They're going to say estimate f prime 2. They're going to say find the average rate of change. Again, average rate of change is just code for slope between 2 points, right? Okay. So if they tell me this, and they give me an h value, instead of saying let h approach 0, they give me an h value. Then all this is simply f of 2.01 minus f of 2 all over 2.01 minus 2, or I could have just put 0.01 there, 0.01. And then this is just a calculation, right? This is just, okay, plug 2.01 into here, plug 2 into here, work it out, da-da-da, get that. Okay, so that's algebra stuff, that's chapter 1 stuff. Estimate the slope, pick 2 points really close together. Here they just use our new terminology where they give you a value of h, right? And so that's just your second point, is all that is. What's that? Oh, good question. So f of 2.01 means take 2.01 and plug them in to the f function for f. So you would take 2.001 squared plus 2 times 2.01. Get your calculator out. Boom, 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 do that. Get those values. As a matter of fact, let's do it real quick. On your calculator screen, right, you just go to your scratch pad probably, and you would go 2.001, what was it, squared, plus 2 times 2.001. Right? So you copy that down. 8, what was it, 006, 001. Would you have to copy down that necessarily? Plug in a 2 there, you get 8. And here this would be 001. Now you divide those. So back on my calculator, I'll subtract 8. Get that. I divide by 0.001. And 6.001 is my answer. Right? Like that. So, work it out. You always want to have the setup. I think you always want to have this part with the F. You always want to have that part written down. Now, the rest of it you can go to your calculator and just do. Right? So, there's going to be some problems on the homework to just say find the average rate of change. You know, which means they'll give you a couple of points. Maybe they'll just tell you H. That's how you get your second point. Or maybe they'll just give you the 2 points. So, there'll be some of that. All right. So let's do one the definition way, the quote long way. So here we go. So you'd be told a function. Somehow, some way you'd be given a function. We're going to be working with equations most of the time. I think your first homework problem they actually give you a table of values. So if all you have is a table of values, you just do a slope calculation like we just did. Okay? And just subtract the y, subtract the x's. That's easy. All right. But here we're going to have this, and they're going to say find f prime of 2. I think there's like 5 of these on the homework where this is what you have to do. Use the definition, the long way, to find f prime of 2. And notice, I'm not saying estimate here. I'm saying equals. This will be the exact slope. Now, we just got done estimating the slope at 2, and we found it was really close to 6, it looks like. But how do we know it's 6? Is it 6.005? I mean, what is it? What is it getting closer? We just know that's an estimate. All right. Well, here's what we're going to do. We're going to use this definition. So the first thing you write down is limit. H approaches 0. All right. Now, notice we're doing f prime of 2. You can kind of think of this as a formula we're just plugging into. I got 2 sitting here where the a is, right? So what's that mean? I got to put a 2 right there where that a is, and I got to put a 2 right there where that a is. So I'm going to write f of 2 plus h minus f of 2 all over h, right? So all I did was follow my formula. I'm doing the slope at 2, so I need a 2 in place of the a, so I put a 2 there and a 2 there. Okay, now, I have to take a little side trip here before we go any farther to another side trip. Well, this is important. They all are. Don't you have to write this down. This little side trip you have to write. If I ask you right now for f of 1, what would be f of 1? What's f of 1? In this problem right here. 3. What does that mean, f of 1? What's that mean to do? Put a 1 in for x into the f function. Now, allow me to show my work a little bit here. So you're basically doing that, right? Which would be 3. I agree. So if I ask you to do f of 5, that would be 5 squared plus 2 times 5. I'm just putting a 5 in place of the x, right? And if I ask you for f of z, what would you tell me? Z squared plus 2z. And I ask you for, if I ask you for f of blob, it's clearly a peanut. Clearly a peanut. If I ask you for f of peanut, you would say what?
Peanut squared.
Peanut squared
Plus 2 peanuts.
plus 2 peanut. Peanut squared plus 2 peanuts. So if I ask you who, I mean, I can't imagine I ever would, but if I ask you for f of 2 plus h, you would write 2 plus h squared. Darn it. 2 plus h parentheses squared plus, correct? If I ask you for f of 2 plus h, that means take 2 plus h and plug it in for the x. Just like you plug the peanut in for the x. All right. So that's a little side trip. I don't know what made me want to do that. All right. So let's go over here.
Are you going to bring us peanut?
Sure. There you go. So let's rewrite the limit. You should write this on every line. Don't get lazy. Okay. Limit as h approaches 0. Now, let's do some colors here. I need, oh, look at that. I guess it did come in handy. I need f of 2 plus h. Oh, what's that mean? It means plug 2 plus h in for x. So we put 2 plus h squared plus 2 times 2 plus h. So that blue thing is that right there. Okay? And then minus, I don't want to use red. Let's do the, oh boy, that's going to be hard to write. I'm going to write in black and I'll circle. Okay, so now I got to put a 2 in. Oh, that won't be bad. Put a 2 in. Well, that's, we can just do that in our head. 2 squared is 4. 2 times 2 is 4. 4 plus 4 is 8. So that's the green thing there is the 8. That's terrible, yeah. It's hard to read. Okay, and it's hard to see. Okay, so that's the 8. All right, next line. Limit as h approaches 0, because that's going to come in handy. I mean, we're going to need that. Matter of fact, it's the whole key to the whole thing. What does limit as h approaches 0 do again? The 2 points become 1. I mean, that's the whole key to this, right? The 2 points becoming 1. So without that, we've got to have that. It's critical. All right, but we get lost in the algebra sometimes. We forget about it. All right, so what do you got with 2 plus h squared? Careful now. 2 plus h squared. 4 plus 4h plus h squared. You got to FOIL that. 4 plus 4h plus h squared. Plus, distribute the 2, 4 plus 2h. And then finally we have the minus 8. And then all over h. Keep going. It's the long way, isn't it? One line. Okay, now the top. What do we got? H squared plus 6h. That's it. The 4 and the 4 is 8. 8 minus 8 is 0. It is not an accident that that happened. That is critical to the problem that those numbers canceled out. Because now, what can happen? You can think of this as dividing each thing by h. You can think, I prefer to think of it as factoring out an h, but it doesn't really matter. But because those constants canceled out, or zeroed out, that allowed me to now factor out an h. Now but I don't want to diminish that step. That is critical right there, because remember, when the 2 points become 1, what was the problem with 2 points becoming 1? Spencer? Poof. The slope formula disappeared. It went to 0 divided by 0. I mean, think about this now. If anywhere up here, we would have said, well, if h is just going to get close to 0, let's just let it be 0. Well, we know, poof, that's no good. We can't let the slope formula should fall apart. But let's just say we forgot that for a second for some reason. And we put a 0 in for h right here. We'd have f of 2 minus f of 2, which is 0 divided by 0. Oh, and then we'd remind ourselves, oh, well, that's not going to work. We can't do 0 divided by 0. That's undefined. That's no number. And if we'd have tried to put a 0 in for h right here, 0, 0, 0, we'd have 8 minus 8, which is 0, 0 divided by 0. Well, that's no good. But right here, when those two red things cancel out, That's what was causing the 0 divided by 0. If you put a 0 in for h, 0 for h, now that they're gone, we don't have that problem anymore. Now, I know we talked about when you solve an equation and you lose a solution, all that stuff. We're okay with that in this situation. We're not solving an equation. So what we're down to is this. Okay, the h is canceled, now we got this. Now let's think about what we're saying. I mean, it's easy to get lost in the weeds here because we had all these steps, so we kind of forget what we were trying to do. We're trying to find the slope at 2. We're letting the 2 points become 1. We're saying, okay, this is the slope, okay, as the 2 points get closer and closer. So remember on the spreadsheet, those points were getting closer and closer to 2, right? Well, here, on the page before, we had 6.001, remember that? I think what's happening, the slopes seem to be getting closer and closer to 6. Well, now we can tell exactly what's happening. Because right here, we're down to this. As h gets close to 0, what happens here? We got 6 plus something really close to 0. And the closer h gets to 0, the closer this gets to what? 6. Exactly 6. Right? So as h gets really, really tiny, it's almost like it wasn't there. As a matter of fact, at this point, it is okay to go ahead and now plug the 0 in for h. Not until then could we have plugged the 0 in for h. But once those canceled, we can now do that. And so our final answer is 6. And sure enough, that is the slope of the tangent line. Exactly. Okay? Alex, you might want to copy some of this down. Man, you're going to have to do this. Yeah, just soaking it all in. All right. 6 is the slope of the tangent line. Now, let's real quick graph this. Let's just go on our scratch pad and graph this thing. I'll just do it real quick here. What do we got? X squared plus x. No, 2x. Right? X squared plus 2x. Let's look at that. It's parabola. Let's trace real quick at 2 because we're looking for the slope at 2. So if I type in a 2, does it look reasonable that the slope is 6 there? I would say so. It's pretty steep. It's positive. I would say it's reasonable that the slope is 6 right there. Now, of course, this calculator can do so many fancy things. It could do menu, analyze, dy dx is another phrase, something we'll talk about in the next couple of days. Another term for derivative. I can type in derivative. It'll want to know where. I can type in a 2, hit enter, and there it is. That's really a short one, isn't it? Okay? And there's the...
Why didn't we just...
Well, to be honest, I can't think of any time ever on a quiz or anything else you'll need to do what I just did there, but I'll show you. Okay, so it's not a big skill. I don't care if you can do it or not. But you have the thing there. Go to menu, analyze graph. Dy dx is derivative. It's another way of doing derivative. You can see where it comes from, right? Changing y over changing x. It's like slope. And then it asks, where do you want to do the slope? I just typed in a 2, hit enter, and it put it there. Okay? But that's, like I said, being able to type that in calculator doesn't do anything for you if you don't know what a derivative is and can't do it. So that's why we're doing all these things anyway. All right, so it's kind of nice to see. Let me give you one to try on your own, and then we'll get going on homework here. But this time let's put some units on it. Let's talk about rate of change as opposed to just slope. Let's talk about position in miles per hour. So let's say I gave you a position function. Okay, this is actually one in your book. I think they call it D, so what the heck, let's call it D. This is going to help you with one of your homework problems. You can just use the result we're going to get right here. Let's say we had this D function, and D for distance. This is miles now. And it's 10t plus 15t squared, I believe, is the function they use. And they want to find d prime at 2. Now tell me, if d is miles, what am I finding? And t is hours. What am I finding if I do d prime at 2? Miles per hour, the speed, at 2 hours. So at 2 hours, this would be finding the speed, but it's still the same thing. So I'll help you get started with the first step. Limit, as h goes to 0, d of 2 plus h, right, instead of f. We're doing it at 2 again, so that goes in for the a. minus d of 2 all over h, correct? All right. Go ahead now and try to mimic what we just did in that previous problem on this problem. See what you get. Okay, I'll uncover kind of one thing at a time here. And you can look up or not look up if you might need to. Actually, when we start chapter 2, then hang up. This is your chapter 2 assignment. Okay.
Hey, we have to do this all by tomorrow, right? Yeah.
Every line.
Yeah.
I mean, it is AP. All right. It was easy to see. All right. So there's my first step. If you want to take a look, right? Just plugging in 2 plus h. Think peanut. plugging in 2 plus h where the t is. So that whole blue thing was the first part. Remember, that's the second point of the 2 points we're doing the slope on, the 2 plus h, right? That's the green point from that other thing. It's the second point. So that's the y, and then 80. Okay, and so then we FOIL and distribute.
I have a question.
Yes.
Can you explain why the 80 is negative?
Well, just because the formula's minus.
I realized like halfway through that it had to be negative.
Yeah, it's just because, remember, this is slope formula, so this is y2 minus y1.
Okay.
And so it's just in the formula, it's minus, yeah. Okay? So, yeah, so what's going to happen, so I did part of it and I FOILed out the 2 plus h and then I distributed and things combined and the 80s then canceled here, okay, which again is a key thing that they did cancel. It needs to happen because if those don't cancel, those 80s don't cancel, then you can't factor out an h. Okay, you can't factor out an h and have that be able to plug the 0 in. So you had 20 here, and 15 times 4 is 60, so 20 and 60, that makes 80. 15 times 4h makes 60h plus the 10h, that's where you get the 70h. 15 times h squared, right? The 80s drop out. Here we factor out an h, which is really the critical component of that. And now, as h approaches 0, what do we got? 70, right? 70. So at 2, so if this was a miles function, a distance function, this would mean at 2, the velocity, the miles per hour, was 70. Okay, now there's a problem on your homework. I think it's number 6. Your homework is that top line now. Okay? Of the sheet I just gave you. And if you've got some questions about what we just saw right here, I'll answer them for you as soon as we get going here. But so you got the rest of the time to work on homework. So the top line on your assignment sheet, okay, let's just take a look at this just to get you going. Okay, number 1, I'm on page 87 now. So maybe we ought to get our books out and get open to 87.
I was gonna say that would help.
I don't mean to rush through this, but I do want to leave you a decent amount of work time here, and so then if you do have some questions about some of this, you can ask each other, or you can ask me. So the questions on the homework are essentially going to be a couple of things. There's going to be some, and I'll point out which ones, where you do it this long way. They call it the limit definition or the definition of the derivative or something like that. There's about 5 of those, and I'll show you which ones are. Then a lot of the rest of them are just asking you to do average rate of change, like they give you 2 points. Somehow in there they're giving you 2 points, so you just do a slope calculation. So that didn't take very long. And then there's other questions where they're just asking you about this whole concept of what it is you're doing. Okay, and so you got to think your way through that. So if you look at number 1, it says let d be the function in example 1. Estimate d prime of 2 using, and then they give you 2 points. Well, if you go back to example 1 on page 81, it's just a table. So all you can do is do a slope calculation. So they gave you the 2 points. The table's right there on page 81. So you got your y's, you got your x's, do a slope calculation. Okay? Number 6. I want to talk about this real quick, and then I'll tell you which ones you need the long way. Number 6 says, find the equation of the tangent line that's tangent to the curve y equals 10t plus 15t squared. Well, that looks familiar. 10t plus 15t squared, okay? At the point 280. Okay, equation of a tangent line. What do you need for that? Equation of a tangent line.
Slope.
Point and a slope. Well, you really only need 1 point if you have the slope. If you have 2 points, you get the slope, but you need a point and a slope. Well, they give you the point 280. Now, what's the slope? What's the slope of that function at 2? We just did. So you don't have to redo it. So for number 6, you can just use what we just did, the 70, along with the point they give you to write the equation of tangent line. So that's easy. Okay, 7. They give you a function and they say find f prime and negative 1 by mimicking the computation example 3. Well, that's this. So 7 is a do it the long way one. Okay, 7 is do it this way. And so is 41 through 44. Okay, so if you want to mark that, 7 and 41 through 44 are ones where you do it this way. Okay? The rest of them are all just slope between 2 points, or they just ask you questions about the process of what we're talking about. All right, good work. And if you got some questions about this, please